In the late summer of 1859, the sky caught fire. From the snowbound plains of the Arctic to the sun-drenched shores of Cuba, the heavens bled with colors never before witnessed by living memory. Vibrant curtains of crimson, green, and violet light danced across the night, so brilliant that miners in the Rocky Mountains woke and began to prepare breakfast, believing the dawn had arrived hours ahead of schedule. This celestial display was a spectacle of impossible, terrifying beauty. On the ground, however, a strange new magic was at work. Telegraph systems, the nascent nervous system of a modernizing world, suddenly went haywire across Europe and North America. Operators watched in disbelief as sparks flew from their equipment, delivering painful electric shocks to the unlucky. Some machines burst into flames, while others began transmitting messages on their own, powered by a ghostly current flowing not from their batteries but from the very air and earth around them. What haunted the globe on that September morning was not a phantom. It was a message from our star, a ferocious whisper of its true power, delivered across 93 million miles of empty space. We now know its name, the Carrington Event. It was the most powerful geomagnetic storm ever recorded in human history, and it stands today not as a historical curiosity, but as a chilling prophecy, a silent warning of a threat that grows more potent with each passing day. Our sun is the engine of life, the giver of warmth and light. We see it as a constant, a serene presence in our sky. This perception is a profound illusion. The tranquil yellow orb is in fact a chaotic, violent nuclear furnace, a roiling sphere of plasma governed by magnetic forces of unimaginable complexity. Its surface is a tempestuous ocean where colossal arches of incandescent gas, larger than a dozen Earths, rise and fall in a perpetual fiery ballet. Deep within this celestial engine, immense bands of magnetic energy twist and shear. They are like titanic rubber bands stretched to their breaking point by the star's rotation. Sometimes these colossal fields of force snap. The resulting explosion unleashes a torrent of energy, a flash of radiation known as a solar flare, which crosses the void at the speed of light. Minutes after such a paroxysm, high-frequency radio communications on our world can vanish. This initial blast, however, is merely the muzzle flash from a far greater weapon. The true danger lies in what follows. Often these magnetic detonations hurl a colossal bubble of solar material into space. 1 billion tons of charged particles, a cloud of superheated plasma, is ejected from the solar furnace at millions of miles per hour. This is a coronal mass ejection, or CME. It is a cosmic cannonball, a fragment of the Sun itself shot across the solar system with astonishing force. Most of these eruptions miss our world, harmlessly dissipating into the interstellar dark. But sometimes our planet is directly in the crosshairs. When the 1859 tempest was unleashed, the journey took just under 18 hours. A cloud of stellar matter, once part of our central luminary's atmosphere, collided with Earth's protective magnetic shield. This invisible bubble, the magnetosphere, is our planet's first and last line of defense. It is a dynamic field generated by the molten iron core of our world, constantly deflecting the solar wind and harmful cosmic radiation. It preserves our atmosphere, our water, and our very existence. Against a CME of the Carrington Event's magnitude, even this shield buckled. The plasma cloud struck our planetary defense with unimaginable violence, compressing it on the day side of the globe down to a fraction of its normal size. The impact caused the Earth's own magnetic field to fluctuate, wildly unleashing a torrent of energy that was channeled down toward the magnetic poles. This immense influx of particles supercharged the upper atmosphere, igniting the atoms of oxygen and nitrogen to create those spectacular global auroras. The sky's conflagration was the beautiful symptom of a planet under assault, while the heavens shimmered, a more insidious effect was taking hold below. A rapidly changing magnetic field at the surface induced powerful, uncontrolled electrical currents in any long conductor. In 1859, the longest conductors man had built were the telegraph wires that stretched for thousands of miles across continents. These phantom currents surged through the lines, overwhelming the primitive systems and turning a revolutionary technology into a fire hazard. The planet itself had become an enormous electrical generator. The world of the mid-19th century was robust and analog. The damage from the solar outburst was contained a strange anecdote for the history books. Our civilization today, however, is a fragile crystalline palace built on a foundation of electricity. We have wrapped our planet in a web of technology 1,000,000 times more complex and 1,000,000,000 times more vulnerable than those humming telegraph wires. Our modern society is an intricate machine, and its lifeblood is the stable flow of power. This sprawling network is our single greatest achievement and our most profound weakness. Imagine a similar solar paroxysm striking us now. The initial flare would arrive in 8 minutes, potentially crippling radio communication. Then, a day or so later, the invisible tidal wave of plasma would make contact. As the magnetosphere reeled from the impact geomagnetically induced, currents would begin to flow through the arteries of our civilization, our power grids. These are not the small, manageable currents that grids are built to withstand. They would be titanic surges of direct current, an alien form of electricity that our alternating current systems are utterly unequipped to handle. This rogue energy would surge into the grid's most critical components, the large high-voltage transformers that are the irreplaceable heart of the network. These colossal machines, some the size of a house, would begin to saturate. Their iron cores would rapidly overheat, literally melting from the inside out. Within minutes, hundreds, perhaps thousands of them across entire continents could be destroyed, tripping circuit breakers and plunging vast regions into darkness. This would not be a temporary blackout. This would be a catastrophe. The great transformers are the silent titans of our era. Each one is a bespoke piece of engineering costing millions of dollars. They are incredibly difficult to build, requiring specialized factories and materials, and they take months, sometimes years, to manufacture. They are so massive, they can only be transported by specially designed rail cars and ships. We do not have a stockpile of them waiting in a warehouse. If a significant portion of a continent's transformers were fried simultaneously, they could not be replaced for a very, very long time. The initial loss of power would be just the beginning of a cascade of failure. Without electricity, the pumps that deliver clean water to our cities would stop. Sanitation systems that carry away waste would fail. The global distribution of food relies on a constant chain of refrigeration which would instantly break, leading to spoilage on a massive scale. Fuel pumps at gas stations would cease to function, paralyzing all transport. Our entire financial system, which exists today only as digital bits in servers, would evaporate. Our reliance on another, even more exposed technology complicates the peril. A fleet of thousands of satellites orbits our world, forming the brain of our global society. These delicate electronic systems are bathed in the harsh radiation of space, barely protected by the magnetosphere's outer layers. A Carrington-class event would be a death sentence for many of them. The storm's particles would bombard their sensitive electronics, causing short circuits. The atmospheric drag from a super-energized thermosphere would pull them from their orbits. The loss of these orbital assets would be devastating. GPS satellites which govern not just navigation but the precise timing signals for banking networks, cell towers, and even the power grid itself would go dark. Weather forecasting, critical for agriculture and disaster response, would become impossible. Global communications, from television broadcasts to long-distance phone calls, would vanish. The internet, whose data flows through undersea fiber optic cables, powered by vulnerable land-based stations and repeaters, would face continental fragmentation. We would be deaf, blind, and isolated in a world utterly dependent on being connected. A new dark age could descend not from ignorance or war, but from a silent, invisible tempest from 93 million miles away. This is not hyperbole. A 2013 report from Lloyd's of London estimated the cost of such an event to the North American economy alone could be as high as $2.6 trillion. The study concluded that recovery from the most severe scenarios could take anywhere from 4 to 10 years, an entire decade, to rebuild the basic infrastructure of modern life. We have received warnings. In March of 1989, a solar storm far less powerful than the Carrington Event struck the Earth. Its induced currents found a vulnerability in the long transmission lines of Quebec's hydroelectric power grid. The entire province was plunged into a blackout that lasted for 12 hours, a stark demonstration of how a celestial phenomenon could have concrete, disruptive consequences on the ground. It was a tremor before the earthquake. A far more serious alarm was sounded on July 23, 2012. On that day, one of the most powerful coronal mass ejections ever measured erupted from the Sun and blazed out into the solar system. By sheer cosmic luck, it erupted from a region of the Sun that was not facing our planet. The CME tore through the Earth's orbital path, but our world had passed that exact spot just 9 days earlier. We missed a direct hit by the slimmest of margins. Had that eruption occurred a week and a half sooner, we would be living in its aftermath today. Most of humanity was completely unaware that our technological civilization had just dodged a bullet of cosmic proportions. Scientists who studied the data from the Stereo A spacecraft which flew through the storm confirmed its power was fully comparable to the 1859 event. It was a sobering reminder that these superstorms are not relics of a distant past. They are a clear and present danger, a loaded gun that our parent star periodically points in our direction. The question is not if another will occur, but when. So why is this threat becoming more likely every day? The answer is twofold, residing both in the heavens and here on Earth. Our star moves in cycles of activity, waxing and waning over a period of roughly 11 years. During the solar minimum, its surface is placid and calm. As it ramps up to solar maximum, its face becomes mottled with sunspots, the cradles of magnetic instability where flares and CMEs are born. We are currently ascending the slope of solar cycle 25, predicted to reach its volatile peak around the middle of this decade. As the sun's activity increases, the frequency and intensity of solar storms naturally rises. The statistical probability of a Carrington-class event striking the Earth is estimated to be somewhere between 1 and 12% per decade. Those are not the odds of a distant, abstract risk. They are comparable to the chances of other major natural disasters for which we diligently prepare, like a catastrophic earthquake on the San Andreas Fault. The sun's cyclical behavior means the cosmic lottery is being drawn more often, but the most critical factor in this rising danger is our own relentless progress. The likelihood of a catastrophe is a product not just of the hazard itself, but of our vulnerability to it. With each passing day, our dependence on fragile technology deepens. Every new satellite we launch, every smart device we connect to the network, every community we link to, an ever more interconnected power grid we add another potential point of failure. We are methodically weaving a more intricate and therefore more delicate web. Our global infrastructure was built for a world we assumed was electrically benign. We designed our power systems to handle terrestrial threats like lightning and ice storms. We did not engineer them to withstand a geomagnetic cataclysm from space. This oversight has left us exposed on a planetary scale. The very interconnectedness that gives our grid its strength and efficiency in normal times becomes its greatest liability during a solar superstorm, allowing a localized failure to cascade across an entire continent. Our intricate design multiplies the risk exponentially. The race is now on to confront this silent cosmic threat. Knowledge is our first line of defense. A constellation of solar observatories both on the ground and in space now keeps a constant vigil on our volatile star. Satellites like the Solar and Heliospheric Observatory and the Dies-Cova spacecraft act as our celestial sentinels, watching for the telltale signs of a dangerous eruption. They can provide us with a crucial, if brief, window of warning. The initial flash of a flare gives us minutes. A CME in transit offers us hours. With enough warning, utilities could take precautionary measures. They could strategically disconnect certain assets, reroute power flows, and bring the grid to a lower, more defensive state of readiness. This could mitigate some of the damage, but it is not a complete solution. A truly massive storm could still overwhelm even a prepared system. The only lasting answer is to harden our infrastructure itself. Engineers have developed solutions. Installing blocking devices could prevent the flow of harmful DC currents into transformers. Upgrading circuit breakers and control systems could make the grid more resilient. The most important step would be to build and stockpile a strategic reserve of those critical high-voltage transformers, ensuring we could begin the process of reconstruction in months, not years. These are not technologically impossible goals. The obstacles are primarily economic and political. The cost of a comprehensive grid hardening program would be substantial, running into the billions of dollars. In a world of competing priorities and tight budgets, it is difficult to justify such an immense investment to protect against a threat that is low frequency and poorly understood by the public and policymakers. It is the ultimate challenge of preparedness, spending a fortune to prevent a disaster that may not happen for another 100 years or could happen tomorrow afternoon. We are gambling with our entire way of life on the sun's continued good temper. We exist in a state of profound cosmic fragility. We have constructed a gleaming electronic civilization on a tiny wet rock that orbits a middle-aged variable star. For millennia, our connection to that star was one of simple reverence and gratitude. We looked to it for warmth, for seasons, for life itself. Now we must recognize it for what it is, a source of immense and unpredictable power, capable of creation, and if we are not careful, of utter devastation. The Carrington Event was not an attack. It was an incidental consequence of a star's normal violent life. The sun does not care about our satellites, our power grids, or our digital society. It is an engine of physics operating on a scale that dwarfs human concerns. The next great storm is already brewing within its turbulent depths. A knot of magnetic energy is twisting, straining, and one day it will break. The resulting blast will travel silently through the void, an invisible messenger carrying a simple truth about our place in the universe. That truth is that our technological prowess has outpaced our wisdom. We have built a world that is breathtaking in its complexity and power, yet we have failed to appreciate its dependence on the stable conditions of our small cosmic neighborhood. We have forgotten that the same laws of physics that allow a smartphone to function also govern the terrifying explosions on the surface of a nearby star. The future of our modern world may depend on our ability to finally learn that lesson. The clock is ticking, illuminated by the fires of a distant, indifferent sun.